I'm Anil Kumar sharing with you one of the most popular question in application of trigonometry, Ferris wheel. We'll have 7 multiple choice questions based on this particular concept. The problem here is the height of basket on a Ferris wheel is modeled by h of t equals to 20 minus 18 sine of 2 pi by 3 t minus 1, where h of t is height above the ground in meters and t is time in minutes. Sketch graph and answer multiple choice questions. So I'd like you to pause this video, sketch the graph of this function, and then look into these multiple choice questions. Let me share the questions first, then we'll go through their solutions one by one. The first one here is, find the height of the basket after 75 seconds. Question 2. When will the basket be 20 meters above the ground? Question 3. What is the maximum height of the basket? Question 4. When will the basket reach its maximum height? Question 5. How much time will the basket take for 3 full rotations? Question 6. Distance traveled by the basket in 2 minutes is what? And the last question is, the angular velocity of the basket is one of these 4. So I hope the concept is clear. You can now answer these questions and then look into my suggestions. Now let us try to answer this particular question without calculator, right? So we'll prefer not to use calculator. In some test, it may not be required. So we'll do without calculator. Especially for IB students, it is part of the question where the calculator will not be allowed. Okay, now before we sketch, let's figure out what parameters are given to us. This 20 here is actually the axis, right? So the axis is 20. Amplitude is 18. Time period, let's say t, is, since k is 2 pi by 3, it should be 2 pi by 2 pi by 3. So it is 3 and the units are minutes, right? So time period is 3 minutes. Now from here you can always get the maximum and minimum. So the maximum will be, you have to add axis and amplitude to get 38, and minimum is going to be the difference, which is 2, and the units are in meters, right? Now with that, it is very simple to sketch the graph, and this is probably the fastest way of answering such questions. Now let's say that is the x-axis. So what I normally do is sketch the minimum, which is 2 for us. So this dotted line indicates the minimum. Maximum is this line for us, and the axis is somewhere in between, right? So this becomes the axis. Now clearly the axis is 20, so we can write 20 here. Maximum 18 plus 20, which gives us 38, and minimum is difference, so it gives us 2. Now sine wave, you see this negative, it means after shifting 1 unit to the right, it actually goes down, right? So sine waves goes downwards. Therefore the graph should be kind of like this. Let us say it goes down from here, and we'll just draw one wave, right? So let's say that is what one wave is, right? Now since it is t minus 1, that should have been 1 unit, and the time period is 3, so that means 1 plus 3 is 4, right? Now each quarter is 3 divided by 4, which is 0.75. So this could be, let me write 1.75, and this is 2.5, and then that is let's say 3.25, right? 0.75 less than 4, and all these times are in minutes, right? So these times are in minutes, t. The height h is in meters, right? So let me write meters here. That gives you the height. Now once you sketch, then it becomes really very simple to answer all the questions, right? Let's look into it now. So even a rough sketch like this will really help us to answer these questions in no time. The first one is find height of the basket after 75 seconds. Now 75 seconds means what? You have to convert to minutes, right? So basically 75 seconds is 60 plus 15, right? 60 plus 15, or 1 minute and a quarter of a minute, right? So in minutes it is 1/4 of a minute. So if I substitute that for t, I get h of let me write 1.25 here, equals to 20 minus 18 times sine of 2 pi by 3, and here I have 1/4 minus 1. See, the importance of quarter is, now the difference is very easy. It is 1/4, right? So I'm just trying to show you the calculations, how we can do very easily without calculator, right? So 2 pi by 3 times, so that difference is 1/4. Do you see that? 1/4. And this can be simplified. You could divide this by 2. So you get pi by 6. So once you get pi by 6, you know your special triangle, right? So in this special triangle, where this is 90 degrees, that angle is pi by 6. Sine of pi by 6 is half. So this gives you 20 minus 18 sine of pi by 6, 2 times 3, which is 20 minus 18 times half, and that is equal to 11, right? Which is, you could write 20 minus half of this is 19, so that gives you 11. So option C is the right option. So the whole idea is to explain you a very simple way of getting to the solution, right? So you'll appreciate that, see, we used mixed numbers, and that really helped us to find the solution. Now let's look into question number 2, which is when will the basket be 20 meters above the ground? So since it is 20 minus, so it is 20 minus something, right? Only if this becomes 0, it will be 20 meters. So when will sine become 0? Sine of this will become 0 when t minus 1 is 0. So that is when t equals to 1 minute, correct? So if t equals to 1 minute, in that case, we have 18 sine 2 pi by 3, and here we have 1 minus 1, which is 0, right? So that makes this portion 0. Do you get the idea? So it is, when will the basket be 20 meters above the ground? And from our diagram which we made, the basket is 20 meters above the ground at t equals to 1. So if you look into your sketch, the answer is straight there. You don't even have to calculate, right? Now let's look into the third question, which is what is the maximum height of the basket? So it is 20 plus 18, right? Which is 38. And also we have done it in the sketch. We know the maximum is 38. The next is, when will the basket reach its maximum height? So the basket will reach the maximum height, if you get back to this, 3.25, right? So that is the third quarter, it reaches the maximum height. So after 3.25 minutes, so third quarter, 3, basically we are saying 3 full and a quarter, right? So that is 3 times 4 is 12, 12 plus 1, 13/4, right? So the option D is the right option, correct? Next, question number 5 is, how much time will the basket take for 3 full rotations? Now, for one rotation, it takes how much? Time period was 3 minutes, right? So for 3 rotations, it should be 3 times 3, which is 9 minutes. Clear, right? So 9 minutes is the answer. Question number 6. Distance traveled by the basket in 2 minutes. Now we know in 3 minutes, one full circle, right? One full circle in 3 minutes, which is 2 pi r, right? Which is 2 pi r, r being amplitude 18, so which is 2 pi times 18, right? So that is the distance covered in 3 minutes. So in 2 minutes, it will be 2/3 of this, right? So less distance, 2/3 of this. So in 2 minutes, it will be 2 pi times 18 times 2 divided by 3, correct? So if you simplify this, you could divide 18 by 3, it goes 6 times, and 6 times 4 is 24. So we get 24 pi as the answer, which is option C. So I hope you can find it very simple how to solve this question without calculator. Right? Now we are at the end of the question. We have to find angular velocity of the basket. Now angular velocity is radians per second, and now we know it is 1 revolution in 1 minute. 1 revolution means 2 pi, correct? So it is 2 pi radians in this case it is 3 minutes, right? 1 revolution, we know time period is 3. So 2 pi radians in 3 minutes. So basically we have to find in how many seconds, right? So radians per second is the unit. So we can multiply this by 60 to get our answer. Is that okay? So once you do that, we can simplify this. 2 will go 30 times. And so we have pi over 90 radians per second, which is option C for us, correct? So that is how you can actually answer all these questions. Now getting back to our the very first page, you will appreciate how important it is to kind of sketch the function. It gives you a clear idea of where we are heading, and it helps to get the correct answers. I hope that helps. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thanks for watching and all the best.